50 million people gone. Not from a world war, not from a plague, from the weather. One single weather event, and scientists are now saying the exact same thing is forming right now, under the Pacific Ocean, as you watch this. Most people, and I mean like most people, think El Niño is just a slightly warmer year, maybe some extra rain, maybe California gets a bit soggy. But here's what they're not telling you in the weather report. There's a version of El Niño so extreme, scientists gave it a completely different name. They call it the Super El Niño. And it doesn't just tweak the weather, it rewrites it, globally. By the end of this video, you're going to know something that most people, including people who watch the news every single day, have absolutely no idea about. You'll understand why scientists are genuinely scared right now, and why the year 2026 might already be the most consequential year for weather in the last 150 years. Stick around, because this story starts with some Peruvian fishermen takes a detour through one of the deadliest famines in all of human history, explodes across your TV screen in 1997, and then lands right here, right now. All right, so let's go back, like way back, to the 1600s off the coast of Peru. You've got these small fishing communities working the Pacific, and every few years, not every year, just sometimes, the ocean off their coast gets weird. It gets warm, unusually warm. The fish disappear, the skies change, and these fishermen, brilliant, observant people, they notice it tends to happen around Christmas, so they gave it a name, El Niño. In Spanish, that means the little boy, or more specifically, a reference to the Christ child because of the Christmas timing. And for a few hundred years, that's all it was, a local weather curiosity named by fishermen. Nobody had any idea it was actually a planet-scale machine. Okay, so here's where the science gets genuinely wild, and I promise I'm gonna make this dead simple. Picture the Pacific Ocean as a giant bathtub. Under normal conditions, the trade winds, these massive, consistent winds blowing west across the equator, they push the warm surface water toward Asia, toward the Western Pacific, Indonesia, the Philippines. Those regions get warm, wet, tropical conditions. Meanwhile, on the other side, Peru, Ecuador, the ocean is actually colder because the warm water got pushed away. Deep, cold water wells up from below. That's actually amazing for fishing, by the way. Cold, nutrient-rich water. Great for anchovies. Okay, so far so good. That's normal. Scientists call this entire system the Walker Circulation, named after a British meteorologist, Sir Gilbert Walker, who identified it in the 1920s. It's basically the atmosphere's conveyor belt above the equatorial Pacific. Now here's what happens when it breaks. So imagine someone, let's say the atmosphere, just stops blowing. Those trade winds, they wobble, they weaken. And the moment they do, all that warm water that got pushed west, it starts sloshing back east. Like when you stop blowing across your bathtub, that water rushes back. And as that warm water moves east, it heats the air above it, which weakens the winds even more, which lets more warm water move east. It's a feedback loop, a self-amplifying spiral, and that spiral is called El Niño. The trigger is a pulse of warm water traveling east underwater. Scientists call this a Kelvin wave, and once it hits the coast of South America, game over. The warm water rises to the surface, the eastern Pacific heats up, and suddenly, the entire global atmosphere has to reorganize. Weather patterns that have been stable for decades just shift. Now, not every El Niño is a Super El Niño. Most are pretty tame. You get a warm year, some weird storms, some drought here and there, and then it's done. But scientists have identified only 3 confirmed Super El Niños in modern recorded history. 3. 1877, 1997, and 2015. That's it. Each one crossed a specific scientific threshold. Sea surface temperatures in the Central Pacific more than 2 degrees Celsius above normal, which sounds tiny. It is not tiny. 2 degrees in ocean temperature is like the difference between a campfire and a blast furnace in terms of atmospheric energy. Each of these 3 events changed the world in measurable, documented ways. And right now, in 2026, models are projecting a 4th one, and potentially the most powerful since 1877. Actually, quick pause. I want to know something. Before we get into the absolute devastation of 1877 and 1997, drop a comment below. Did you know El Niño could do this? Or just write, I had no idea, if this is blowing your mind so far. Because honestly, most people have no idea the scale of what we're talking about. Let me know where you're from too, because where you live will totally determine how this next one hits you. All right, back to 1877, because this is where it gets dark. The year is 1877. The world has no satellites, no radar, no weather stations worth talking about. Nobody has any idea what's about to happen. And yet, underneath the Pacific Ocean, the largest Kelvin wave in recorded history is rolling east. Surface temperatures in the Central Pacific are about to exceed 3 degrees above normal. That number, 3 degrees, will literally cook the world's monsoon systems. The Indian monsoon? Gone. Fails for 2 consecutive years. The Chinese river systems? Drought so severe the Yellow River runs dry in places. Brazil? The Northeast turns to dust. The African continent? Widespread crop failure. And here's the brutal, darkest part of this story, and I don't want to gloss over this. The famines that followed were amplified by human decisions. Colonial governments in India under British rule continued exporting grain while tens of millions of people starved to death. This wasn't just a weather event. It was weather plus policy, weather plus power. The final death toll from the 1877 to 1878 Super El Niño and the famines it triggered? At least 50 million people. Some historians put it higher, closer to 60 million. That is roughly 3 to 4% of the entire global population at that time. To put that in modern terms, 3 to 4% today would be around 250 to 300 million people. That's the entire population of the United States, dead, from one weather event and the political decisions made in response to it. This was documented in devastating detail by the historian Mike Davis in his landmark 2001 book, Late Victorian Holocausts, which argued that these famines were not natural disasters. They were the intersection of natural forces and imperial indifference. Think about that. The 1997 to 1998 El Niño is widely considered the most powerful El Niño event in modern recorded history, meaning the era when we actually had satellites and instruments to measure it properly, and it went absolutely everywhere. In California, one of the wettest years on record, storms dumped over 38 inches of rain in San Francisco in a single season. Mudslides swallowed hillside homes. Sinkholes opened up on highways. In Indonesia, the opposite, the worst drought on record. Fires burned across 9.7 million hectares of forest. The smoke was so thick it blanketed neighboring Malaysia, Singapore, and Brunei. Peru and Ecuador, catastrophic flooding. Mexico, brutal hurricanes. East Africa, flooding and malaria outbreaks as mosquito populations exploded in the standing water, all at the same time. One planet, one weather event, total chaos. And here's one that most people have absolutely no idea about. While 1997 to 98 was destroying the weather on land, it was doing something catastrophic underwater that we are still paying for today. The superheated ocean temperatures triggered the largest coral bleaching event in recorded history. When water gets too warm, coral expels the algae living in its tissue. That algae is what gives coral its color, and more importantly, its food source. Without it, the coral turns ghost white and slowly starves to death. In 1997 to 1998 alone, an estimated 16% of all coral reef systems on Earth died, completely gone. The Great Barrier Reef, reefs in the Central Pacific, the Indian Ocean, all scorched. Entire ecosystems that had been growing for thousands of years wiped out in months. Scientists described it as the worst coral bleaching event in recorded history, until the next one came along. When it was all over, the 1997 to 1998 El Niño was estimated to have killed approximately 24,000 people directly and caused $34 billion in economic damage worldwide. The air temperature globally temporarily rose by 1.5 degrees Celsius above normal, which was 6 times the usual El Niño warming. The anchovies off Peru essentially vanished. Peru's fishing industry, which is among the largest in the world, collapsed. And for context, that single-year temperature spike, it briefly crossed the Paris Agreement's key 1.5-degree guardrail that the world's nations later agreed should never be permanently crossed. El Niño crossed it in a year, by itself. So here's the thing, and this is the part where we get a little nerdy, but stay with me because it is so worth it. Scientists have a very specific definition for what separates a regular El Niño from a Super El Niño. It comes down to one number, the temperature anomaly in a stretch of the Pacific called the Nino 3.4 region. Think of it like a thermometer for the entire Pacific. Under normal conditions, that region is right around average. During a regular El Niño, it might be 0.5 to 1.5 degrees above normal. That gives you an unusual year. But when it crosses plus 2 degrees Celsius above the long-term average, that's the threshold. That's when it graduates into Super El Niño territory. And currently, as of May 2026, subsurface ocean temperatures in the equatorial Pacific are running 6 to 7 degrees Celsius above normal. That heat hasn't surfaced yet, but it's coming. And when it does, right now, and I mean literally right now as you're watching this, there is a Kelvin wave moving beneath the Pacific Ocean. Scientists at NOAA detected it in early 2026, and by April, the subsurface heat had ballooned to something nobody had seen in generations. The ECMWF. That's the European Center for Medium-Range Weather Forecasting, basically the gold standard of global climate modeling, released its May 2026 update showing a 100% probability of a Super El Niño forming by November 2026. Not 80%, not 90%, 100%. Central Pacific temperatures are projected to exceed 3 degrees Celsius above average by autumn. The last time we saw numbers like that, 1877. The last time we saw a level this high forming underground, before it even surfaced, never. In modern records, never. So what does a 2026 Super El Niño actually do to the world? Scientists have mapped this out in detail, and the projections are not comforting. Australia, severe drought in the east, where most of the population lives. Indonesia and the Philippines, drought, crop failures, fire risk. The Indian monsoon, disrupted, which means food security for over 1 billion people becomes uncertain. Peru and Ecuador, extreme flooding, because the warm water right off their coast supercharges rainfall. California and the U.S. Southwest, elevated rainfall and storm risk in winter 2026 to 2027. The Atlantic hurricane season could actually be suppressed. El Niño increases wind shear in the Atlantic, which tends to weaken hurricanes. And globally, scientists estimate that even a moderately strong El Niño in 2026 could push the average global temperature to 1.7 degrees Celsius above pre-industrial levels. That's not a climate model projection decades from now. That's potentially next year. And here's the thing that makes scientists genuinely lose sleep over the 2026 event, and what separates it from every previous Super El Niño in history. The baseline has changed. When El Niño hit in 1877, the global average temperature was just normal. When it hit in 1997, the baseline was already slightly elevated from early industrial-era warming. But now, in 2026, we're already at approximately 1.2 to 1.3 degrees Celsius above pre-industrial baseline, before El Niño adds its kick. Climate scientist Deepti Singh put it perfectly. What is different now is that our atmosphere and oceans are substantially warmer than they were in the 1870s, which means the associated extremes could be more extreme. It's like, imagine you have a fever of 100 degrees. Now add El Niño on top of that. The compounding effect is what nobody has ever seen before, in any historical record. You know, for all the satellite data and Kelvin wave measurements and temperature anomaly thresholds, it's easy to forget that every decimal point in these projections represents actual human lives. In 1877, it was the farmers of Madras who watched their fields crack open like old pottery, the fishermen of Peru who came home to empty nets and couldn't feed their families, the families in Hunan province, China, who buried their children in ground too hard to dig properly. In 1997, it was the Indonesian families who ran from wildfire smoke so thick it turned noon into midnight. The California families who watched mudslides carry their neighbors' homes down a hillside at 3 a.m. Weather is never just data. It's always people. So, and this is the question everyone wants to ask, are we actually better prepared than they were in 1877 or even 1997? Honestly, yes and no. We are much better at predicting it. NOAA, the ECMWF, Japan's meteorological agency, they have satellite arrays, ocean buoys, and ensemble models that can see a Kelvin wave forming months before it surfaces. That's genuinely incredible. We can see it coming now. In 1877, nobody saw anything. But, and this is a big but, seeing something coming and being prepared for it are two completely different things. Global food reserves are tighter today than many analysts would like. Many of the world's most vulnerable populations live in exactly the regions a Super El Niño hits hardest. And unlike 1877, we already have climate-stressed agricultural systems, coral reefs half destroyed from previous events, and aquifers being drained faster than they recharge. The tools are better, the world they're being used in, arguably more fragile in some key ways. Here's the thing that I want you to walk away with, and this is the part that most weather coverage completely misses. El Niño has always been with us. Long before humans were around to name it, the Pacific was cycling through these swings every 2 to 7 years. It's as natural as the seasons. The 1877 disaster wasn't purely El Niño's fault. It was the collision of natural weather extremes with political failure and imperial indifference. The 1997 disaster wasn't just El Niño, it was El Niño meeting a world that had already started warming the baseline. And 2026? The Super El Niño forming right now is natural. The atmosphere it's arriving into is not entirely natural. That's the new equation. Weather happens, it has always happened. The question is what kind of world the weather lands in. And that question, that's a human one. So, let's loop back to where we started. 50 million people, one weather event, 1877, and now, 149 years later, we can see the next one forming. Deep beneath the Pacific right now, a Kelvin wave is traveling east. It will surface. Ocean temperatures will spike. The atmosphere will reorganize. Weather patterns across the globe will shift. We know this. The instruments are screaming it. The models agree. And here's the remarkable, kind of amazing thing about that. The fishermen who named this thing in the 1600s, they just knew the fish disappeared. They named it after the Christ child. They had no idea they were describing a planetary machine that would one day be tracked by satellites in orbit 400 miles above Earth. From Peruvian fishing boats to global supercomputer models, the story of El Niño is, in a lot of ways, the story of humanity learning to read the planet. We're getting better at it. Let's hope fast enough. Now, if this left you wanting to know exactly what's going to happen when the 2026 Super El Niño actually hits, country by country, season by season, I've got a full breakdown coming, because there are some countries that will barely feel this, and there are others that are looking at back-to-back catastrophic seasons, and the difference between them might surprise you. Hit the subscribe button, hit the notification bell, because when that video drops, you're going to want to see it first. And hey, go drop a comment. Tell me, are you in a region that gets hit or one that gets spared? I'm genuinely curious where you guys are watching from. See you in the next one.